Thank you very much for attending this session. Today, I'm going to talk about probabilistic critical path, or if you like, critical chain computation. We learned CPM, which is purely deterministic model. We also learned PERT, which has some probabilistic nature. But in this talk, I'm going to explain simulation in project control. The problem remains the same as it was. Still, we have a network. Technical precedence remains the same, no change. For example, A is still precedence for C and D. Both D and E are precedence for F. So there is no change in technical precedence. The change is in duration of activities. For example, if in a deterministic model, the duration of an activity is 2 days, here we may say the average is 2 days and standard deviation is, say, 0.5 days. Or we may say the average is 4, but it is between 2 and 6 days. Different probability distribution may replace that single number which we were using as duration of each activity. Usually, Erlang, triangular, these two distributions are frequently used as a representative of activity time. We can also use normal, but we should restrict the lower bound to something, and especially not going below 0 because we don't have an activity with a negative duration. We may also assume exponential. All of these are possible among other probability distributions. But the key idea is a deterministic number, a single number, is replaced by a distribution. Let's make this change in a simplest way. And simplest way is to assume the activities have uniform distribution. They have a lower and upper value, and the random variable uniformly can move between these two upper and lower bounds. Let's make it even simpler than that. Let's assume activities have discrete uniform distribution. For example, if in a deterministic model we say the activity time is 6, now we may say it is between 3 and 9. And also we may say it's discrete, it is not continuous. So it is 3, it could be 3, 4, 5, 6, 7, 8, 9 with an average of 6. If you made these simplifications, then implementation in Excel becomes extremely easy because Excel has a specific function which can give us random numbers between two upper and lower limits. And that is rand between. Activity A has uniform distribution between 2 and 6. So I come here equal to rand between. Rand between lower, comma, upper. Give me an integer number between 2 and 6. Because I'm going to copy it down, then I should lock those two rows. Here, I'm talking about row 2. I like it. And row 3, I like it. Now I can copy it down. And because I have not locked A, I can copy to the right too and create random durations for other activities. So we just use a function, rand between A and B, which gave us an integer number between A and B. Enter. Oh, I have one X. Enter. And then I copy it to the right. Now here, I am generating a random number between 1 and 3. 1, 2, 3. Here I am generating a random number between 4 and 8. 4, 5, 6, 7, 8. And then I go here. And then I copy this down. I generated 1000 random variables for each activity. Then I go through my network and I identify potential passes from the starting point to the ending point. I will later discuss an approach how to find it out how many passes are in a network. For the time being, it is easy. Just we look into it and we find these three, and we cannot find anything else. We have AC pass, ADF pass, and we have BEF pass, three passes. AC, ADF, BEF. Then I come here. This is equal to A plus C. Enter. Copy to the right. This is equal to A plus D plus F. Copy to the right. This is equal to B plus E plus F. So I created the length of those three passes. Out of those three passes, AC and ADF are critical in this situation because critical pass or critical chain is the chain which takes time more than any other chain. And now, click, and I generated 1000 possibilities. Now I come here, equal to max, because I know the critical path takes more time than any other path. And then click. For example, here I have one critical path, one critical path, two critical paths. Conditional formatting, highlight, the simplest highlight equal to, if this is equal to this, and then I should remove the dollar in front of 5 because I'm going to copy it down. Paint it, and then format paint, and paint this. Now I know, for example, in this situation, all three passes, because they have probabilistic nature, all three passes were critical. So I have created critical paths. Now I want to sort them and create a S-shaped curve. And also I like to compute basic descriptive statistics. So I come here, equal to average numbers, and I allocate a 4. Enter. Let me delete these two columns not to make you confused. So I have average. Because I want to later put it into my graph, I also round it to 1. Enter. The standard deviation, I just copy this down and then replace average with standard deviation of sample, because you only have 1000 observations. Oh, I did it on the top one. Switch it back. Okay, and coefficient of variation is standard deviation divided by average. Copy average, paste average, make it, we really don't need round here. Min, copy it down, max, copy it down, median, copy it down, count. So I have descriptive statistics. Now I know that my critical path may take as little as 6 days or as long as 16 days. Median is 12 days, average is 11.6 days for 1,000 simulated instances that I generated. Now I like to create a shape curve to tell me how I go from minimum to maximum under what probabilities. Obviously, I don't go like a linear because usually due to central limit theorem, when I incorporate several random variables, the final shape should look like a normal curve. Therefore, I expect such a S-shaped curve. I come here, equal to rows. I go to this cell, column, and then I lock the first one. So that is from absolute L5 to relative L5. In the first cell it is 1. If I copy it down, it goes to 1,000. Now if I come here, equal to small, find small of this column and lock it, comma, rows from this one to itself, make the first one absolute. So now I find small 1, I find small 2, I find small 3, and I sort it from small to large. Click. And because I have hidden it here, it goes from 8 to 16. Otherwise, if I unhide it, it goes to 8, 9, 10, 11, 12, and so on and so forth. And here I want to compute probabilities because I have 1,000 observations. They are the first one, the smallest one. The thousandth one is the largest one. So if I go here and divide this by count and lock it, F4, that would give me probabilities. Click. Now what I can do, I can copy this too. Insert, scatter chart. I click on this. A graph comes out. Very strange. But that is because select data, hidden and empty cells, show data in hidden rows. So this is my curve. Here I have written some functions. You may look into them. It is just to create a format. I click on this, equal to this. And then it will tell me what is the average and what is the coefficient of variations. But my coefficient of variations has a lot of decimal points. So I go here to coefficient of variations and I round to 2. So now it tells me the average is 1.8. 1.8. Oh, I have clicked on wrong numbers. The average is 11.5 and coefficient of variations is 17. That is 17 here is 20 because if you like, Control 1, you can change this color to a better color and you can increase this, for example, to 2.5. This is your curve. And you can also click on it, go here and make it darker. And you can also make the fonts to what I like. So that is our graph. And let me tell you how I made this one. I said equal to average and this one and coefficient of variations and this one. Enter. So that appeared over there. But these two numbers are a little bit attached to each other. So I'll go here and I say and quotation space and space quotation, and now it puts an and between those two values. Or if you like, you can just type and here. If it confused you, you can type and, because I don't want that middle and to be confused with the and in the right hand side and in the left hand side. So that is the curve. The next thing that we can do is to compute probability of each path, to be on the critical path. Equal to, if this is equal to this, and I like J, but I leave 5 as it is. If the time of that activity is equal to the maximum, then put 1. Otherwise, put nothing. And then copy to the right. Now AC is critical. Here I have it. Copy it down. Here ADF is critical. I have 1. So I copy this all the way down. And then equal to sum, because whenever it is critical path, I have put 1. That's it. So this one 357 times was critical. This one 703 times. And this one 117. The summation of these three is greater than 1000, which is the total number of simulation instances, because as we saw, in some instances we have 2, and even in some instances we have 3 critical passes. Yeah, it is more than that. And now if I divide what I have got here by count and lock it and copy to the right, these are probabilities of each pass to be on critical pass. Therefore, I can do this. Insert, chart, I insert this one, okay? Right click, select data, horizontal edit, and go and replace these 3 by 1, 2, 3. Now they are changed. Okay. Make sure that the color is good dark and the font is what I like. And then I can go here, click on this one, and for example, make it this color. I can also go here and this gap, I may reduce it to say 25%. I may click on this, equal, and then click on this, which shows me the percentage that each pass is critical. We created a graph to show the distribution of the project, and we create a graph to show the distribution of critical paths. Let me show you a couple of tricks, simple tricks. First of all, I really did not need to use this small function. I used it just to have a practice for you. Excel dynamic arrays have given us a lot of capabilities. Let's use one here. Equal to sort, and I then mark all this column, enter, it is sorted for. So we could have used small function and we have used dynamic arrays. Let me give you a second, which is again based on the capabilities that dynamic arrays bring to a stage. Let me erase this side. I'll go here, I type equal to find what? Find A, B, C, D, and F, and I lock it because I'm going to copy this to the right and to bottom. Find this, comma, here, okay? And I also lock this column 4 because I'm going to copy it down, but since I want to benefit from it when I copy it to the right, I don't lock G. I did that. Let's see what do we get. So we get 1 and 2. I go here and I state is number. If what you see is number, if this is correct, we will have true. Otherwise, we will have false. True, true, false, false, false. If is number is true, comma, put the corresponding value which you see here. And I should lock A, and I should lock F because I am going to copy to the right. I don't lock 5 because I want to copy it down. So if that is correct, put the time. And if it is not correct, put 0. If is number, if you found a number, put the time associated with it. If you didn't find, that means that activity is not inside that path, therefore just put 0, enter. So it puts 2, which is time of this activity, 5, which is time of this activity, and the rest are not there. Then I go here again, and I say, add that 2 to that 5, sum. So now I can easily copy this to the right and copy it to the bottom. A little bit more difficult Excel functions, but easier to automate. I really don't need to go everywhere and enter the time of the corresponding activities. Now again, I can come here, equal to sort. Thank you very much for your time. In another video, I'll go into a little bit more complication in these computations. But we are fine as long as understanding the basic concept is concerned. We got the idea. Oh, one more thing. This was our graph, correct? We used discrete uniform distribution. Now let's go one step further, and instead of discrete uniform distribution, which is generated by rand between function in Excel, let's do it for continuous uniform distribution. Continuous uniform distribution is between A and B. Excel can generate a function called rand, which is between 0 and 1. Now you have a number, you have a random number between 0 and 1, and you want to take it from 0 and 1 and drop it into A and B. How you can do that? Think about it a little bit. So I have something which is called rand. And rand is something between 0 to 1. I want to take it to somewhere between A and B. So I want to take the range of 0 and 1 to range of A and B. This is quite simple. I take rand and multiply it by B minus A. If rand is 0, the result is 0. If rand is 1, it is 1 multiplied by B minus A is B minus A. But I don't want it from 0 to B minus A. I want it from A to B. So how can I go from 0 to B minus A to A to B? I just add A here plus A, and I add A here. What does it mean? I have a function B minus A times rand. I also add A to it. Now I have rand. At minimum, it is 0. At maximum, it is 1. If it is 0, this is 0. 0 times something is 0. Then it will be A. If it is 1, it is 1 times B minus A is B minus A plus A is B. Therefore, I can take rand from the range of 0 and 1 to the range that I am interested in, which is A to B. Let's do it. Instead of using rand between, I come here and I say equal to A, which is 2 for this activity, and I log 2 of A2, plus upper bound for this activity, which is 6, and I log 3 over there, minus lower bound, which is 2, and I log this part, multiplied by rand. Enter. Now this number is 4.6. It is between 2 and 6, but it is not integer. It is a real number. I can copy it to the right. Copy. Look at this curve here when I do click, click. Click, click. Now the shape is very different. The probabilities are here and the graph is here. All were updated. Let me go one step further. This is the same problem, but I have created 3 tabs for you to start from very simple functions and gradually make it complicated. Not complicated, a little complicated. Up to now, we have computed the length of the project, the probability of the duration of the project, the probability of each pass to be on the critical path or critical chain. Now we want to compute the probability of each activity to be on critical path. So I have A, B, C, D, E, F activities here. I can go here and I can use very simple function. I say A is on critical path if AC or ADF are critical paths. So this one would be equal to max of these two, the first 2 paths. B is on critical path if the 3rd path is critical. C if the first path is critical. D E if the last pass is critical, and F max if the 2nd or 3rd pass is critical. So here we have ADF, ADF are critical. And then I can copy this down And then I can go here, sum these numbers, those times that I have observed 1, and then divide it by count. And then I can copy it to the right, and then I can create this graph for activities that are critical. Probabilities of critical activities. But we can do better. Equal to find what? Find A and log 4, because I'm going to copy to the bottom. I log 4, because also I'm going to copy to the right. I don't log T. Find T in these 3 and log it. Is there A in any of those 3? Yes, it is in the first one, and it is the second one, but it is not in the third one. Is number, is it number? True, true, false. Instead of is number, we can also use is error, but then we should have played oppositely. Both of them can handle the job. Yes, true, and false. If is number is true, then put what you see here. Is it on critical path or it's not? And I should log P, and I should log R. Because when I copy to the right, I want P and R remain as they are, but when I'm copying it down, I want 5 to be 6, 7, 8, and 9. That's it. If it is number, if you find it over there, if it is in that path, write what is below it, which tells us whether that is critical path or not. Because it may find A in one path, but that path may not be critical. Okay, we have this. So if you find it, write what you see. Is there 0 or 1? Critical or not critical? And if you didn't find it, just simply put 0. Enter. So we found A. We found A in the first one and in the second one. But the first one was not critical, while the second one was critical, and that is why we see this one here, but we see nothing over there. So now we have these. What is important for us is to see if there is a 1 or not. Max. So we write the max, and we place the max over there. So in this situation, A is not on a critical path because these two are not critical paths, and critical path is here, and A is not there. If I copy to the right, D and F and A are on critical paths. And critical path is here, A, D, F. Now we can copy this down, much easier than the previous one. Not much easier, but much less time consuming. There is a last concept that I also like to include it, and I want to quickly draw a histogram. We go to the next page, which is the continuous version. I have minimum, I have maximum, I can compute range, max, minus, mean. So let's make the mean adjusted equal to int of this one, no matter what it is, max adjusted equal to round of comma 0. So it's between 7 and 16. Type equal to 6. And I type equal to 7. Now it became 7 plus 1 equal to 8. Copy this down. (16 or 17) equal to count if. Count if what you observe here these times and lock it, comma, is less than and this. That means if they are less than 7, and then copy it down, we should end up with 1000 equal to 7. That is cumulative. Now we want to make it for each bin. This one minus this one. Copy it down. And equal to, divide it by count to compute frequency. Count of these numbers and lock it. On this page I didn't have count over there. And then I copy it down. Then I can go here and I can insert chart. This is a chart. I can also go here and type equal to average of 8 and 7 or whatever it is, and copy down. Select data, edit, and then I can place these over there. Okay, okay. I can go here, Control 1. So that is the histogram for the project duration. Thank you very much for attending this session. I hope I have been able to deliver some substance, and I hope you spend time a little bit on this topic, learn it, and be able to implement it in different situations. See you in my next lecture.